Welcome back, guys. अब हम करेंगे current electricity and DC circuit question 14, paper 2 5054. Let's start. A student sets up the circuit shown in figure 10.1 in a laboratory at room temperature. The electromotive force of the battery is 12 volts. As we can see, it's 12 volts. और parallel में एक oscilloscope है parallel to the 1.3 ohm resistor और एक थर्मिस्टर यहाँ लगा हुआ है which is the एक resistor है fixed resistor है एक ammeter है and the point y I don't know yet. The switch is closed. The connecting wires in the circuit are made from copper covered by insulating plastic. State the name of the particle that flows in the copper. So firstly, we have to state the name of the particle that flows in the copper and state the direction in which they are flowing at point Y in the circuit. At point Y in the circuit. ठीक है ना? First of all, they are the particles they are asking us about is the electrons. Firstly, the answer is electrons for the first part. And they're asking for the direction. It will be from the negative terminal to the positive terminal. ठीक है ना? So towards the ammeter, away from the negative terminal towards the positive terminal. So yes, this will be the answer. आगे चलते हैं. At room temperature, the resistance of component Z is 6 ohms. State what is the name of the component Z. The component Z is the only thing which is dependent on the temperature, and the resistor which is dependent on the temperature is the thermistor. Thermistor होता है. Thermistor is the only resistor that is dependent on the temperature. ठीक है ना? That is why they have mentioned the room temperature. And अगर आपको कोई resistor दिखे which looks something like this, right? It is gonna be a thermistor. You have to remember that. So yeah, thermistor. Sorry. आगे चलते हैं. Calculate the resistance of the whole circuit. अच्छा, for the resistance of the whole circuit, we will have to calculate the resistance of this parallel configuration and add that resistance to the series configuration. तो पैरेलल में हमारे पास है एक फिक्स रेजिस्टर विच इज 1.5 और हमारे पास है एक थर्मिस्टर विच इज 6. तो 1.5 1 डिवाइडेड बाय 1.5 plus 1 divided by 6 is equals to 1 divided by R. That is the formula in order to calculate what the resistance is in the parallel configuration. So 1.5 1 divided by 1.5 plus 1 divided by 6 will equal to a 0.8333. ठीक है ना? So if we divide 1 divided by 0.8333, it will equal to 1.2. 1.2 will be the resistance across this configuration. ठीक है ना? अगर आपको ये पता नहीं है कैसे हुआ, I will explain you. तो 0.8333 will be equal to 1 by R, right? तो अगर R ऊपर चला जाए और 0.8333 नीचे आ जाए, तो will we make the R the subject? Yes, we will. So 1.2 will be the total resistance across this. So if we add 1.2 plus 1.3, we will get 2.5, and 2.5 will be the total resistance across that terminal, across that circuit, sorry. Calculate the current measured by the ammeter. The current measured by the ammeter will be the total voltage calculated by the total voltage and the total resistance. तो V is equals to IR से हम निकाल लेंगे ये. V हमारे पास है 12 is equals to I हमारे पास क्या है? I निकालना है. सॉरी, R हमारे पास कितना है? अभी हमने निकाला है 2.5. तो 12 divided by 2.5 will equal to 4.8. 4.8 amperes will be the current. ये आगे चलते हैं. Part 4. The current in the ammeter is IA. So the ammeter में जो current जा रहा है यहाँ से, that is gonna be IA. IA will be the current flowing through the ammeter. आगे, the current in the 1.5 resistor is IR, IR will be the current in the 1.5 resistor, and the current in the component Z is IZ. तो as we all know कि जो करंट होता है ना, that acts differently in parallel, different than the voltage, right? करंट जो होता है that divides. करंट फॉर एग्जांपल अगर यहां से आ रहा है 4 एम्पेयर, 4 एम्पेयर यहां से आ रहा है, तो इट विल डिवाइड हियर, ठीक है ना, यहां आके वो डिवाइड होगा. फॉर एग्जांपल यहाँ 3 एम्पेयर चला जाता है और यहाँ 1 एम्पेयर चला जाता है. So it will divide according to what the resistance is. The less the resistance is, the more current there will be. ठीक है ना? So they are saying कि what, write down an equation that relates IR and IC. So IA is the total current. IA is the total current. और IR और IZ is the current that divided from the total current. मतलब I G plus I R will be equal to IA. ठीक है ना? So this will be the relationship between them. I'm gonna repeat it again. जो current होता है that acts very differently from the voltage because the current जो होता है in parallel it divides according to what the resistance is. And जब यहाँ आएगा current, then it will have a choice, not a choice, मतलब it will have to go either way, right? According to what the resistance is, and some of the current will go here and some of the current will go here. समझ आ गई? तो हम आगे चलते हैं. This is a very easy part. The 12-volt battery is made from cells of electromotive force EMF 1.5 volts, which are all in series. So they are in series. Calculate the number of 1.5 volt cells that make up the battery. अच्छा, जो सीरीज में होती है ना वोल्टेज, दैट एड्स, सीरीज में ऐड होगी वोल्टेज, ठीक है. तो they are asking us the number of cells it would take to make a 12 volt battery. तो हम 1.2 को इजीली डिवाइड कर देंगे 1.5 से, 12 को डिवाइड कर देंगे 1.5 से, we'll get an answer of 8. 8 cells would be needed in order to make a 12 volt battery. State the EMF of a battery made by connecting all of these cells in parallel. So they are saying 8 cells are connected in parallel to each other. What will the combined EMF be? The EMF will still stay the same. It will stay 1.5. ठीक है ना? क्योंकि पैरेलल में जो होता है ना, जो EMF होती है, जो वोल्टेज होती है, few line up cells in parallel, what will happen is they will increase the time it would take for the batteries to run out, but it will not increase the voltage. The total EMF will not increase. ठीक है ना? The total EMF will not increase by adding cells in parallel, although they will increase the time in. ठीक है ना? तो ये मैंने वैसे ही लिख दिया था. टोटल EMF will not increase by adding cells in parallel, although they will increase the time in which the cells will run out. So yeah. So the total EMF will still be 1.5 volts. This statement is just for your understanding. So that is going to be it for this video. I hope you enjoyed. Have a great day. Allah Hafiz.